Well, we're going to go ahead and get started. Thank you so much for coming. Good morning, day two. My name is Rachel Licker. I'm a principal climate scientist with the Union of Concerned Scientists, and I am really excited to be here for this all-star panel looking at the food, energy, water nexus. So I'm going to go ahead and introduce our speakers, then we're going to go into remarks and then Q&A and panel discussion. So we are going to be starting with Dr. Bhartendu Pandey, who is a postdoc at Princeton University in the Department of Civil and Environmental Engineering. His research examines urban areas using multiple lenses, including land use, infrastructure, economic activity, and human mobility to understand their equity and sustainability implications. He uses big data sources such as satellite data, satellite remote sensing data, GIS, national surveys, and social media. And he's particularly interested in inequality, human health, and sustainability implications of urban infrastructure. He earned a Bachelor of Science in Life Sciences from the University of Delhi, a Master of Science in Geoinformatics from TERI School of Advanced Studies, then TERI University, and a PhD from Yale. Then we are going to be hearing from Sara Walling, Culture and Restoration with the Alliance for Great Lakes. She's based here in Madison and has over 15 years of technical and policy development experience in agricultural nutrient management, water quality, and bioenergy from her time having worked with the Wisconsin Department of Agriculture, Trade, and Consumer Protection. Additionally, Sara served as the Agriculture Institute Director with the UW-Madison Division of Extension, where she oversaw county extension agents and agriculture education and outreach programs. She has a Master of Science in Land Resources and Environmental Sciences from Montana State Bozeman, and a Bachelor of Science in Natural Resources and Water Quality from the University of Minnesota Twin Cities. Finally, we're going to be hearing from Chris Kucharik, who is a professor of agronomy and environmental studies. His faculty position is with the Wisconsin Energy Institute, and has affiliate appointments with the Department of Atmospheric and Oceanic Sciences, Agroecology, and Freshwater and Marine Science. He's a member of the Science Council with the Wisconsin Initiative on Climate Change Impacts, or WICI. He's a part of the Great Lakes Bioenergy Research Center, and he is also focusing on sustainability issues related to bioenergy production. His research program is largely interdisciplinary, incorporating field work on cropping systems, ecology, and ecosystem modeling in a framework that's really geared towards understanding the impacts of climate change and land management on the provisioning of ecosystem goods and services. Chris received both his BS in Atmospheric and Oceanic Sciences here, as well as his PhD with a minor in Soil Sciences. And very importantly to me was my PhD advisor, so important to note. So we're going to go ahead and get started, hearing first from Bhartendu, and then we will move from there. So yeah, we'll just hold questions until the end. Thank you. Go ahead.
Thank you, Rachel. Good morning, everyone. I'm going to be talking about urbanization more than the few nexus. And there is a reason, and I'll try to convince you that urbanization is super important. So I want to begin with these two pictures of the Earth. One showing us these complex Earth system processes and biogeochemical functioning that we depend on. The other one is about cities, human activities, and the dynamism. I would argue that we know much more about Earth system functioning than we know about human activities at scale. And this brings me to some of these trends that you may already be aware of. Urbanization. We are living in an urban planet, but we are still continuing to urbanize, going from 3% to 50% in 2007 to almost 88% by the end of this century. This is a big transition, and there are a lot of changes that will accompany these transitions. But I would point out that This is just a demographic change. That means we humans are going to be living more and more in urban areas. But there is a lot more to this process. And this is what I'm going to be talking about today. And I'm going to be focusing on three different elements that links with the few nexus. One is about food consumption. When we are living in cities, do we change our consumption? About land use change. As cities expand, what sort of land use changes are we seeing and expecting? And also about inequality. So let me start off with food consumption. And I'm going to draw upon a research that we conducted looking at urbanization and food consumption in India. And this is a paper that came out in Scientific Reports maybe like 2 years ago, where we tried to show how urbanization is associated with food consumption. We looked at very detailed survey data sets, as well as satellite data sets to examine urbanization. And here I'm showing correlations, strict correlations with urbanization as a demographic process. That means share of urban to total population. And also correlations with income, household income. What we see here is that urbanization is very weakly related to food consumption as compared to household income. That means household income is a very strong determinant of what we consume. And this is known, but a thing that surprised us was that urbanization as a demographic process is not a strong determinant of food consumption, at least in India. We try to investigate this issue a bit more by focusing on quantities of food consumed by households, but also the diversity of food consumed. So we have a portfolio of food commodities that we try to look at, and we quantified how diverse is that consumption. What we noticed is that, again, urbanization, and this is just a result of hundreds of regressions that we ran, just showing maybe like 4 or 5 models here and try to compare them. But urbanization as such has no effect on food consumption once everything else is controlled for, that we feel are the determinants of food consumption. But when we look at all these other aspects, household income, household size, household structure, women working in the workforce, travel times to cities, that means market access, all of these were sort of very strongly related to food consumption. An important piece of information that we argue in this paper is that all these processes, at least in the Indian context and more generally in urbanizing context, are driven by the urbanization process. Now, if I were to examine correlations between urbanization, even as a demographic share, and all of these determinants, they are sort of related, non-linearly, right? And that is to say that urbanization processes are unfolding beyond demographic processes, right? But we try to focus often on just the demographic part. Moving on to urban land expansion, also in India. So we try to look at what sort of lands are we losing to urban expansion as cities are expanding in India. And just to give you a scale of how much land on a decadal basis urban expansion is consuming, it's roughly about 1 million hectares, right? And so on a decadal basis, that is the amount of land on average India is converting to its cities. A majority or a preponderance of that expansion is fueled by agricultural land loss. That means cities are expanding over agricultural lands. And this is expected because cities are located on prime agricultural lands, right? And that's the basis of, one basis of why cities exist in the first place. So we are losing agricultural land, not just in India, also in the US. I just looked up this morning how much land US is losing to agricultural land. It is approximately 1.3 million acres, which is, you have to divide by, I think, or multiply by 0.45, something like that. But there is a substantial agricultural land loss that is happening also in the US. Now, why is it important? One, for local production and local consumption. That really matters, right? But also now the scale of that conversion may not be large, but these causes local issues. But also there are a lot of social and really human implications on these losses. Particularly in the Indian context, there is a significant impact on livelihoods of these households. So once a farmer loses their land, they don't know what to do next. and often they end up in very low-paying jobs, again related to inequality that persist in cities. Um, we try to extend this sort of decadal analysis by looking at more deeply examining this with satellite data. And the thing with satellite data is that nowadays we are getting every image a single day, right? And we have this capacity of monitoring the land at a very high frequency. But I would argue that we don't have good algorithms that can help us detect or monitor these changes at such high spatial and temporal frequencies. So in this paper, we sort of try to put together an algorithm drawing upon time series econometrics to understand when are we losing these lands to different land use transitions. And this is the algorithm that we applied to India to examine at a national scale how much land, agricultural land we are losing annually. And this is the nonlinear dynamic that we saw. Since 2006, we saw a steady increase in agricultural land loss. Now, I don't want to argue or point out the drivers of this expansion, but I do want to say that this is associated with, at least correlated with economic growth and economic policies as well in the Indian context. With that, in my doctoral research, I try to reconceptualize, rethink how our urbanization is unfolding across the planet. And to begin with, we think of urbanization as simply a rural to urban change process, but there is a lot that goes on, right? There are changes in demographics, there are changes in economics, there are changes in the built environment and regional environments and global environments. There are social and cultural changes, there are institutional changes, there are technological changes, all unfolding with urbanization. And all of these changes manifest in a geographical space, right? And these distributions are not often unequal. I mean, they're not equal, they're unequal. And these inequalities manifest across spatial scales. We are thinking about inequalities between neighborhoods. We see that. Between urban areas, we see that. Globally, yes. I mean, across all places, we see all these inequalities. So just to summarize, I'm thinking about urbanization as this multidimensional process that manifests in a geographical space, but it is all characterized by inequalities that plays around. There is a key point that I make here, and this is a paper that just came out in PNAS earlier this year, thinking about infrastructure inequalities and how urbanization is contributing to this. And we looked at very high resolution census data. That means I looked at 700 or so urban neighborhoods and villages in India and South Africa, and also looked at satellite images to see how infrastructural distributions are unequal and what are the characteristics of that. And we developed along the process a novel measurement, infrastructural inequality measurement framework that can be applied across these data sets. So what we found is, yes, urban inequalities do vary across spatial scales, right? But the core finding that we derive from this is that it actually is much higher when we look at inequalities at the national scales. And often when we are thinking about urban inequalities, we often think about urban inequalities within urban areas, right? That they are much higher when we are in it. But it's the opposite, that it's way higher when we are looking at urban systems at national scales as opposed to neighborhood scales. So that's one of the findings, and this is important because, again, these pictures of showing inequalities in urban areas, they are infinitely small as compared to, not infinitely small, but relatively small compared to what we see as inequalities manifesting across urban regions. So this is all from the census data when we looked at different kinds of household amenities, water, sanitation, electricity, housing. But when you looked at satellite data, we found that infrastructure inequality is actually a fundamental characteristic of urbanization. And here on the x-axis, I'm showing a proxy measure of urbanization by looking at average radiance in average nightlight radiance emitted by a region. And on the y-axis, I have a measure of infrastructure inequalities, like how unequal is that region, right? As we progress on this scale from left to the right, we are increasing in the intensity of urbanization. But at the same time, we see a nonlinear increase in infrastructural inequalities as well, which is basically saying that it is locking us in this unequal situation, the urbanization process. And this is all gone unnoticed so far, I would argue, and particularly at scales where it's manifesting more. So I want to come back to this and say that it is unfolding beyond the demographic transition, and we don't yet have a good understanding of how these changes vary across space and time. And this brings me to an important grand challenge in understanding urbanization impacts on other systems, in that these impacts are often spread across scales in space and time. And it is very difficult to understand and attribute these impacts via urbanization. And these are some examples of when and where some of these urbanization impacts manifest. I mean, climate change, it's happening now, but it's also going to happen in the future, all predominantly driven by urban areas, right? And think about communicable diseases, right? Our city is shaped in a fundamentally and in a lot of ways how infections proceeded, right? And there are a lot of research about this, including one that is just going to come out in NPJ Urban Sustainability that we investigated for COVID in India, where we again found urbanization as a strong, determinant of COVID incidences. So just to summarize and talk about a few key takeaways, we need a multidimensional understanding of urbanization, and it's not just a local process. It's a global process, and it's spread across time and scale. And we are missing, I would argue we are missing that point, but also that it is a unfairly unequal process, unfairly because it's not being studied that well. Again, this is my argument, drawing upon the research. And I believe that multidimensional understanding of urbanization can help us understand, but also advance the few nexus, because there are a lot of circularities that we can draw upon when we are thinking of urbanization as a process and what is going on with that process. One example is thinking about crop burning in India, right? I would argue that is fundamentally also driven by agricultural intensification, which is driven by food consumption, which is driven by urbanization. So there are these causal chains that remains. Those are fairly, I would argue, understudied. And my last point, satellite data, yes, we need more algorithms, but we need also data integration with other data sets that are of critical importance when we are thinking about the human activities and dynamism and social outputs. So I'll close there, and thank you for listening.
Good morning, everybody. Thanks for attending. And is Tracy? No, she's not in here, but I wanted to thank her for the opportunity to speak today. So I'm going to take a kind of a broad perspective here and talk about a project that we call Fewscapes. I've got the list of the team members here. So as the lead PI, I joke often that my responsibility mainly is just to write the annual reports for NSF, but a lot of what you see today is contributed by those that are up there on the screen there. So thank you for those that are in the audience today too from the team. So just a little bit of a review. We heard a little bit already about food, energy, water. The way that I'm going to talk about it here is the dependence of food, using water to grow food. We're using food to produce bioenergy right now. And sort of this trilemma among these different segments of society. And, a real question about what we're trying to do in our project is try to advance our understanding of how those three segments work together, and try to come up with some better decision making for food, energy, and water, and also be thinking about ecosystems and the impact that we're having on those simultaneously as we think about moving forward. And I'll be talking about this in the context spatially in the upper Mississippi basin here in the US. So our overarching question on our project is how do these systems in this region respond to, very complex interactions in the social and biophysical world? What types of policies and practices moving forward would help sustain food, energy, water, and ecosystem security and the environment and reduce the risk of abrupt change with a changing climate moving forward? Uh, so just geographically, this is what the Upper Mississippi Basin geography looks like. Includes, most of Wisconsin, Iowa, Illinois, part of Missouri, and Minnesota. And everything that we do on the landscape here has an impact downstream. One of the main questions that we grapple with right now is water quality impacts of agriculture, not just here in the US, but around the world. And our connection here in the landscape is that things we do here have an impact all the way down to the Gulf of Mexico. And you might be aware of things like the dead zone, the hypoxic zone, where these nutrients get carried down, unfortunately, and create havoc for biological life there. We also have a few subregions that we're doing more sophisticated modeling in, but I won't get into the details though in this talk. So the questions, these are the key questions. Just to summarize kind of in simpler words and what's up there, historical look at what the trade-offs have been, looking back over the last half century or so. Second would be what would happen if we introduce new policies and sort of a local to global connection. Things like if we were to tax fertilizer applications in the US as one example, or water withdrawals as another example. What types of policies, might help move sustainability, forward in food, energy, water. And then last, what types of combinations and conditions might we have that would help sustain, or maybe things we want to left behind that might erode the security of food, energy, water components, and how might we be able to anticipate those and avoid those by thinking more holistically about these together. So the categories and sort of the output, and I'll talk a little bit about modeling and how we use that to support these studies. We're looking at sustainable development goals from the UN. So you think about food production is an obvious one. Water quality and water quantity are also a focus. But then right there in the middle is energy production. And today I'm going to highlight quite a bit about the renewable fuel standard, how we've used modeling to study the environmental outcomes of that. And thinking more about, corn, ethanol, biodiesel from soybeans. Maybe it's second generation cellulosic biofuel from grasses as maybe another alternative moving forward. So we have to rely on modeling at a large scale because basically we can't do all sorts of experiments everywhere on the landscape. So modeling allows us to fill in the gaps in our understanding. We take, excuse me, results from field experiments that we do on the landscape. Those help to calibrate and validate our modeling tools. And then we scale up and run scenarios across large scale. So some of the questions I have here, if we decide to do something different with the 30 to 40% of land area that's devoted to growing corn and going to corn ethanol, would that help advance our goals for food, energy, water? If we replace some of that cropland with perennials to help support second generation biofuels, or if we start planting cover crops, what might that mean to water quality down the road? So in a nutshell, my group, we do a lot of land surface ecosystem modeling. I've been developing this model, Agri-IBIS, for a better part of probably 20 to 25 years now. And it's basically a system numerically that represents the chemistry, the physics, things that go on in nature through equations. It's basically growing things, it's cycling carbon, water, energy, and nutrients through the system. And it's providing outputs at the end of the day, like how much food do we produce? How much nitrate might be leaching to groundwater? How many calories might we be producing across a large scale from different food crops? And from a remote sensing and sort of satellite perspective, think of this model as running at every individual pixel at some spatial scale. And that can be variable depending on whether we're running at a watershed scale at 30-meter pixels or at the whole scale of continental US at maybe 1 kilometer or 2.5 kilometers. These models require a lot of spatial temporal input data, excuse me, to be able to study historical impacts and identify these future solutions. So think of different data layers. You've got climate and daily weather, something about soil texture, and then crop type and land management is sort of another input. So we are in a movie theater, and I felt like it'd be fun to show you a movie here of the annual land cover. There we go. There we go. So this is produced from satellite data. So this is our reliance on trying to understand what's actually been happening, let's say over the last half century or so. That information's fed into our models in a historical context so we can study, okay, we've been doing these things. What ultimately has this had on impacts to food production, water quality, carbon sequestration, and whatnot. Another data set that we use is inputs from nitrogen fertilizer to cropping systems. So that's actually derived from census data or county sales data for fertilizer. But in order to know where to put that on the landscape, we have to rely on satellite data and land cover. So we're not just randomly distributing it. It is matched to the different crop types and something we know about the types of requirements and inputs and numbers that go to that. But you can see, obviously, in the Corn Belt and in the Mississippi Basin, the dominance of both food crops and the amount of nutrients that are going on to produce that food. All right. So one other model that we also use and are relying on is a hydrologic transport model, which essentially takes the outputs of drainage and things coming out of agro-IVUS on the landscape, so that may be phosphorus or nitrogen or soil erosion, that gets routed into this other model that's based on a digital elevation model that basically routes those through the river and stream network through a basin or through the whole Mississippi Basin for that matter. And that allows us to quickly study the connections between what we're doing on the landscape for land management to water quality and water quantity issues downstream. So the important thing from this figure is just sort of showing the connections between the models, but the gray boxes sort of over there on the left, the historical irrigation, historical nutrient applications, and historical land use and land cover, that's all coming from some derivative of satellite data. And without it, we would be hard pressed to be doing as good of a job as we've been able to. So let's talk about a little bit about the renewable fuel standard. So you might be familiar that in 2007, the US went forward with the idea that by 2022, this year, we'd be producing 36 billion gallons of renewable fuel, 15 billion gallons of that actually coming from first generation corn grain ethanol. And the difference of that would be coming from cellulosic ethanol or second generation, basically taking plant material, breaking it down into that fuel and then using that for transportation support. So in 2008, a colleague of mine, Simon Donner, who's at University of British Columbia now, and I published a paper that was forward-looking and thinking about what might happen with this idea. And 2008 was sort of a year when there were all sorts of studies that were published about the RFS and how we weren't really considering the environmental impacts potentially from that large energy policy in the US. Span together 14 years later, I'm highlighting the work that myself and some others in my group did with Tyler Lark, who's in Center for Sustainability in the Global Environment here with Holly Gibbs, and looked at using our modeling tools and some other things, what were the environmental outcomes of this over the last 15 years? And I just want to say that Tyler and that group, like to help support that study, relies entirely a lot on satellite data and land use change. That's what Tyler's expertise is in, and he's been on in DC, sort of talking about these things and in policy to policy decision makers. But it's sort of looking at that difference in abandonment or expansion of cropland during this time period. And a lot of that expansion of cropland has come at the expense of grasslands and other land that was in the Conservation Reserve Program, which was a set-aside program to help control soil erosion, among other things. So we've seen this drastic shift, and our models have basically told us that increased corn acreage has contributed to increased greenhouse gas emissions, more soil erosion and degraded water quality, both surface and towards groundwater. So it's unfortunate that we've kind of pointed in that direction. So I just want to conclude with a couple points. So, how can remote sensing science, help guide us towards this long-term view, sustainability and security and resiliency? So obviously by documenting the land use and management changes on the landscape to support our modeling tools. Those models are being used to help drive and support policy decision-making. We're in the middle of that right now with our team. To help us form a better understanding of fuel responses to a changing climate and global change, and maybe help us to identify and design a mosaic of land use and corresponding policies that hit the SDGs for humanity in the long term. Seems like a lofty goal, but someone's got to do it, right? So the last point I want to make is we really need to start eliminating policies that create unintended negative consequences of increasing production, whether it's for food or energy. Historically, there's many examples where those policies have been developed in their own silos. Produce more food, produce more, biofuel, RFS, or maybe something to do with water. And the US has had a historical sort of long time period of having sort of the whoops when it comes to some of those. And this paper that we've got coming out sort of highlights some of that. We really need to be more integrated in policy decision-making. That's really difficult though for policymakers to be thinking and wrapping all those things together, and also then including ecosystems as part of that in the discussion. So here's the website link for our project. I'd say we're about halfway through. It's going to be a 5 to 6 year project, or maybe a bit longer if NSF allows us to do that. So thanks a lot for paying attention, and we'll hear from Sara next. So thank you.
Well, good morning, everyone. As she's pulling up my slides, I'll just go ahead and get started a little bit. It's a pleasure to be here among this team. I've worked with Chris a lot over the 15 years I've been working in Wisconsin, and most recently made a job change from, as Rachel pointed out, about 6 months ago, from working for the state Wisconsin's Department of Agriculture on the food water nexus very closely for the last 15 years to policy, the arena, through the Alliance for the Great Lakes. So my talk here is an attempt to bring us up several levels, a lot less of the modeling and data, to really just discuss how we at the Alliance are utilizing satellite imagery at this point in time to inform our policy decisions and policy area geographic focuses, as well as really trying to just get a handle on how we can use satellite data in water quality situations to inform public health decision-making as well. So just first, what is the Alliance for the Great Lakes? Not everyone knows about us, but we are a nonpartisan, nonprofit organization that works across all of the 8 Great Lakes states and with the 2 provinces in Canada on a number of Great Lakes water issues. So not just on the quality front, but as well as with the Adopted Beach program as a big volunteerism component of our work, where we do a lot of beach cleanups several times a year. We also were very much a part of moderating the discussions around the Great Lakes Compact, which puts some parameters on water use and water removal from the Great Lakes region and from its basin. Also a lot of invasive carp work relative to the Brandon Road project, for instance, to keep invasive carp from the Mississippi River Basin out of the Great Lakes. So those are some of our flagship things. And over the last several years, the recognition that harmful algal blooms are also certainly a huge component of concern for our Great Lakes region and all the people that rely on the Great Lakes for water consumption, for their drinking water. And that's where I'm going to focus my portion of today's talk. So at the Alliance, we pay very close attention to this phenomena that happens at this point on an annual basis to various sections within the Great Lakes system. The Western Lake Erie Basin has made headlines over the years with its Toledo water crisis in 2014, where the harmful algal bloom there got to be so large that it shut down the entire water system for the entire city of Toledo and all of its residents for several days, and continues to be a huge cost to those communities, not just the large ones like Toledo, but a lot of the smaller ones that make up the Maumee River watershed. So we pay very close attention to the satellite data provided by a number of sources, certainly, but this one coming from the National Centers for Coastal Ocean Science, and keeping track of those, because this is a picture of the Western Lake Erie Basin and sort of HABs moving in there on the seasonal basis. And so keeping tabs on how this is growing is very important, certainly for informing those communities. And as wastewater treatment plants are forced to consider and be prepared to deal with the harmful algal blooms and the microsystems that they produce, to be able to clean that up, to be able to make sure that our citizens have the drinking water that they need, they end up really ramping up costs due to sampling and testing and the monitoring to make sure that they understand what the levels of production and algae and the microsystems are and what they need to combat. And then certainly the cost to actually treat that water to get it to a place that we can consume it as humans. Similarly, we have a growing concern that's been in existence for quite some time as well, and the Bay of Green Bay, outside of the Green Bay, so that's a picture of it there, as well as the harmful algal bloom development through the satellite imagery that we're seeing in the Lake Winnebago system that feeds northward to the Bay of Green Bay. And certainly a special focus for me as a Wisconsinite in our work. Equally as interesting, in my opinion, I think, is to use satellite imagery to identify potential sources of what is actually causing this. So, much better than to just put a Band-Aid on the problem by fixing the water quality issue itself, or, the treat the water, is to go to the source to really identify what's driving these harmful algal blooms and what can we be doing to prevent that. Most interesting, and sadly, in my opinion, is that Lake Superior was often deemed to be too cold to be able to support harmful algal bloom activity. And what we're seeing is that is no longer the case. They're not nearly to the extent and severity that we're seeing in the Bay of Green Bay or the Western Lake Erie Basin, for example. However, it's encroaching into that. And this is a small picture, which is unfortunately not the best one I could pull from late satellite imagery, but you can identify that kind of pinkish hue there is an image of this sediment coming out of some of those main tributaries to those areas of Lake Superior. And the recognition is there that a lot of that, delivery of sediment in this case, but the nutrients that come along with it, or the surface runoff that is coming from agricultural operations, and that growth of agriculture in various zones that previously, in this case, really hadn't had that kind of land use taking place. So what does this all mean, of course, for us as humans, and what do we want to do with this data? Like I was initially talking about, it's really important to help those communities identify and be prepared for being able to treat the water. So on certainly the Band-Aid side of this issue, because at the time of, we need drinking water. Our citizens, have a right to access to clean drinking water. And so those wastewater treatment plants have a responsibility there. However, to try to diminish the costs that they have, we'd like to be able to use satellite data to more accurately predict when those blooms are coming, so that they can maybe reduce the upfront costs that they may have to have for sampling and the testing of those samples, to get prepared to understand what kind of levels of the pollutant and biological treatments need to take place. So overall, ideally reducing costs to the ratepayers then, because those costs for cleanup of that water does just get transferred down to us as individuals living within those municipalities. So interestingly, I was just watching another webinar this morning, or earlier this week, excuse me, on this exact issue. So it's been really interesting for me to see that the North Central Water Network has been focusing on this. They have a HABs team within their network that has been putting on a lot of very specific additional research work, et cetera, on how we can use remote sensing to identify and work through harmful algal blooms, be able to understand their microsystem development processes, and then ideally be able to use it in cases like this. This is stolen from that webinar earlier this week, to demonstrate how New York is using this to identify when and where, and sort of develop decision-making structures around when to close beaches for public access as a result of what they're seeing through the satellite data. Now I'm going to shift gears just a touch, because my interest, and I think really where we need to go, and this ties back to a lot of what Chris and Bhartendu were talking about, which is this food, water, energy nexus, and how do we, do a better job societally to work through some of this. And there's certainly been a lot of interest in working to provide more sustainability to our agricultural systems. And the Climate Smart Ag Commodity Program is a great example of that of recent days. Over $2.8 million has been funneled into over 70 projects across the United States. Most of them are multi-state level, to be able to try to get at this problem of, what the point of the program itself is actually to be able to open up market opportunities for commodities that are deemed climate smart, so agricultural products. So how do we take this gallon of milk and identify that it is now a climate smart gallon of milk? Well, it has to do with making it the supply chain, everything that leads up to generating that gallon of milk from the cow, making those more sustainable and climate friendly. And so what that means is, and what I worked on for 15-ish years with the department, was really working with individual landowners, cooperatives, et cetera, to incorporate more conservation practices and more carbon sequestration practices, a lot of the things that we think of in agriculture to reduce soil erosion, reduce our nutrient losses, et cetera. All of that really is the things that get built into making a climate smart product and commodity. And this program in particular, with its ridiculous price tag, which is great to see this level of investment from the federal government, so I don't want to diminish it by any means, but this is a lot of money that we are pouring in federally. It's unheard of, and certainly in my career, to have this kind of level of dollars being funneled into agricultural systems to improve their sustainability across the supply chain. So it's great to see. However, I would argue that we definitely need to create mechanisms to ensure accountability is there within each of these projects. So how are we making sure that with these billions of dollars worth of money funneling to these projects and ultimately to the landowners and farmers that are creating the corn that's feeding the cows that's making the milk, how do we make sure that that corn is being produced sustainably and with true climate smart practices incorporated? There's a lot of things that can be done on a paper. Nutrient management plan can be just a paper product, but it's putting it to implementation that's important. And so this is an opportunity, I think, through these projects to use satellite data to do something that's otherwise extremely difficult for us in the conservation agriculture realm, which is verifying the actual implementation of those activities on the landscape. It takes, a lot of bodies, a lot of human resource, a lot of time to be able to go through and identify on the right day, the right timing of the season, that farm did their no-till, that they actually applied their manure when they said that they were going to, and within the correct windows, that they have the cover crops out there, and that the above ground biomass is sufficient to be able to capture the carbon that they're claiming and getting paid for. And so satellite data has a really strong draw for us, I think, in that nexus, because it reduces the amount of labor necessary to go do windshield surveys on those kinds of things. It allows us to refine and really dial into specific fields. And this is, of course, not being done necessarily just by people like me who are interested, but with all of these dollars on the line, I think there's going to be a ton of oversight and eyes on these projects. And I feel like this is a really great way to capitalize on the use of satellite data to be able to make sure that we're getting the crop residues that we're paying a farmer to produce, to incorporate and reduce their soil erosion and nutrient losses with that. And so that's actually about it to wrap it up. And so I think I'll pass it back to Rachel for any questions you guys might have for us. Thank you.
Sheldon drove off ball airspace. So this is not my area of interest, so I have just like a really rudimentary question. I think that whoever wants to take it. So it seems like, based on the three presentations, we're making some good advancements here in the US. I'm curious to know kind of globally, would it be fair to say like Europe, Australia also doing pretty well, but how's the data and progress in like Latin America? Wondering if we're making good advancements there, or if we're
So I'll say that I think they're doing good too. And in fact, there's some satellite platforms and things that are being launched out of other countries that US scientists are using. I think of Sentinel as being one of those. But I would, and there's also US scientists that are also studying problems in those other areas too. So, but I think the US is always probably going to have some advantage in some of these areas of, you know, research in terms of, even though Sarah's saying the funding recently that's being put forth is, you know, uncharacteristic, but we have a lot of people studying, you know, these issues, but I think also that's going on in some of these other places too.
So I can speak of data availability at least in the Indian context, because that's the region I have studied the most, and I feel like the data sits, but is far from academia and even from practitioners. Much of it is not digitized. These measurements may sit in a public office, but no one knows that this data exists. Often we discover that the data is there. So, and that's the bottom of data. On the satellite data side, we have the same problem for satellite data that the Indian government procures through its space agency. In that, much of the data that has been collected is often not in the public domain. But that data is really important because that data was calibrated for the Indian context, starting from the pixel size, the spatial resolution of it, thinking about the fact that we have a problem with clouds, and when we are thinking about agriculture, we need to be able to see through clouds. So thinking about radar data sets, that but of course, Sentinel offers that ability to clouds. And I would say that the third issue is that of the capacity, and our ability to process and understand. Again, inequalities in skill, this is a huge concern. I would say that there is a huge opportunity.
I'm going to go ahead. Oh, I'm going to just jump in and then I'll come into an audience question. So I was curious, just thinking about, Chris, what you were, the point you made about the need to have policies that are integrated, such that we're not kind of robbing Paul, so to speak. I was curious, maybe Sarah, and then all of you, if you can speak a little bit to thinking about, maybe from the private sector perspective, for example, what are some disincentives actually for, more integrated policies, and sort of thinking, if we're going to sort of backtrack from the policies that we need to have to the research that needs to happen to kind of make the case for those kind of more integrated policies. Anyway, yeah, if you could speak a little bit to what some of those kind of the way we currently frame them, or that leads us to this point of siloed policies and how we can maybe think to how to make the case for maybe all of them.
Sure. Well, I would say partly in the context of self-preservationist for myself is I think that there is a lot of need for people who have heavy science backgrounds that can understand the kind of data that projects like Chris is developing and creating, and put that into a policy context and really kind of bring it to a level that policymakers at the in our Congress, at both at the state level, of course, certainly, but also at the federal level, can use that to incorporate into bigger policy packages like the Farm Bill, for instance. But the problem, one of the things I recognize though from my chair over the years has been that, it's difficult because we've been telling farmers what it is that they need to be doing now to reduce their soil erosion, plant cover crops and, put in buffer strips and those kinds of things. And as more and more data is generated, we're identifying that it's not quite so straightforward often, and it's not a one size fits all, that's the silver bullet. And I think some of the disincentive comes, in my opinion, on the agriculture side is this confusion, if you will, over, well, I thought that you've been telling me to do this for years, and now you're telling me not to do that anymore because it's not nearly as protective or sustainable as we maybe once thought. And so that kind of a cyclical, we tend in policy, I think, to jump on the shiny object and really produce programs. And we've, been guilty of this in our state too, of incentivizing certain types of practices with very little real data to demonstrate that that's a long-term solution. And so, we've gotten into that kind of a cycle, and it's very easy for policymakers to hang our hats on one of those success stories and try to, replicate that across a huge agricultural landscape in this case. And I think that's, just that kind of a cycle of jumping on those things somewhat prematurely has created a situation largely of disincentivizing land use and land management changes at the farm level in some cases.
You want me to keep going? Well, I mean, it's really difficult, obviously, to come up with these integrated policies, starting, with things that Sarah's, alluding to. And I think that the science is still not mature enough to be doing that also. And I just would point from personal experiences. 20 years ago, I write a proposal to NSF or an agency, and I'm doing my thing in my silo. How does climate change impact crop productivity? Pretty straightforward, right? Move ahead 20, 25 years later. Now, when I submit to certain programs, I have to have an economist on board, other social science going on, because as the science is maturing, we're basically directing those calls for research to say, you need to be working together to help craft and understand what are the economic impacts of these different decisions, and that's been, from someone who's trained in physical sciences, was very difficult at the beginning. I remember some of the first conversations I had with Dina Rissman, who's a co-PI on our viewscapes, social scientist. People said, you need to go talk to Adina. She's really good with these things to do with land management and policy. And okay, and after sitting with her for 10 minutes, I didn't understand hardly anything she was talking about. And I said, I think you're perfect for this role. Leap of faith, and it worked out beautifully. Adina's great. But it's, like learning from each other, learning what each other needs. I'm still trying to learn more from the economists. I'm working with one at Purdue University who's pretty well known in his field, and we're getting there, but it's slow, and I think we understand, like, trying to sell an integrated policy or idea to a decision maker is pretty tough when they want, like, give me the number. Which one of these scenarios gives me a sustainability rating that's the highest? It's got to be one number. I don't want to see what the trade-offs are. I just want to know what the one number is, because that's what I understand. So I don't know, it's been fun. It's been rewarding. I mean, we've been a part of, connecting with the decision makers now as part of Viewscapes. Also, the last 2 weeks, we've spent 2 hours each with each state hub and with a regional hub talking about scenario development for the future. And it's been very interesting to hear the differences regionally between Iowa versus Minnesota versus the hypoxia task force and what they think the future should look like. And you can read between the lines on what you think the differences between Iowa and maybe a group that's trying to improve water quality in the Gulf of Mexico is. So anyway, if I say more, I'll get in trouble, but yeah.
So in my research, at least thinking about agricultural land loss in particular in India, a lot of growth of cities is, as you would see often in scientific papers, but also in news articles, that it's quote unquote haphazard and that it's not well managed and planned. And even though that's partly true, a lot of it is managed and planned, but it's the scale of urbanization, that just makes things go out of hand. In agricultural land conversion, thinking of this integration of society and policy, there's a case study of agricultural land conversion in Pune. This is a city in the state of Maharashtra, where also Mumbai is. And so in that city, the government came in and said, we are going to establish a special economic zone, which is to say that we are going to export software and things like that. That was all part of the trade liberalization story that started in 1990s, early 1990s in India. And so in that particular case, the farmers got together. They collaborated with the developers, but also with the local government. And they ensured that the benefits of that conversion were shared or at least fairly amongst all stakeholders. And that is to say that as scientists, I feel really good about it because the researcher who studied this case was engaging with these people, right? So that was one element. The second is thinking about how we are producing science, right? And the value of co-producing science is something I think is really important, thinking about integrated policies and coming out of this academic lens. And also recognizing the importance of equity, and not just distributive equity, but procedural equity in that who is being engaged and ensuring that everyone who participates is a stakeholder and understands the process. And the third thing is about understanding and recognizing the people's needs, and that is recognition equity, right? And we have to be thinking about all these simultaneously. I would argue that that cities in particular, and that's something we work with a lot, are very responsive to novel ideas, thinking about integrated policies, and are very responsive often. I would leave it there.
Thank you so much.
Hi, thanks for the talks. I'm Scott with Olson Consulting, Madison. I think it's helpful for academic presentations to kind of have a couple practical takeaways, like that consumers, taxpayers, farmers can easily relate to. And I'm not saying this has to be every all the time, but and I think this may help, but tell me what you think. Would it be helpful to say the price of energy is going up, the cost of fertilizer is going, and in the United States, this is usually a dollar issue, monetary issue. So fertilizer costs going up, I'm going to use less fertilizer this year in my crops, or I've got to quit using fertilizer in my crops and rotate because it costs too much. And the price of potatoes are going up by so much because of this. I think throwing some of those things in there would be helpful to reach more people.
Yeah, thanks a lot for that. I think it's often, it's a hard thing sometimes to describe and put into context for the normal everyday person, I guess. And sometimes what I try to ask people promote is like, what do you value as a person in society? Would you be willing to pay more for X, Y, and Z if we were paying farmers to promote clean water or carbon sequestered in soil and things like that? And I think the reaction immediately is like, well, wait a minute, the price of food's going to go up, right? If I decide to support those, and maybe temporarily, but if we start shifting programs around, things like, Sarah brought up the farm bill and where subsidies are going, we might be able to get there. But it is hard to communicate those types of things and trade-offs, but I appreciate the perspective and keep us thinking about that.
I would add to that point, particularly as an early stage researcher coming just out of finishing my PhD last year, in that a lot of students are really interested in issues that affect the people more directly. And often there is a disconnect between what is being taught in the classrooms and what are the expectations of the society from academics. I think we have getting students started right from the beginning. And this is based on my personal observation and experience. So I would just at that point.
Yeah, I would very much agree with that. I'm sort of in a position where we're doing a lot of that translational work and actually are trying to do more and more trainings for students to understand, like, what does it really mean to ask a policy relevant question, and that whole process, sort of from the whole life cycle of a project. Yeah, I would agree.
Yeah, thanks. My name is Kucharik. I'm with International Institute for Applied Systems Analysis in Austria. Really interesting talks. Thanks very much. I had one question to Bhartendu and then one just to the panel. So you talked a lot about the inequalities in infrastructure availability in urban areas. I was wondering if you did anything specifically on shelter inequalities, because of course there's the global settlements data, and there's increasing interest in sort of looking at inequalities in shelter quality and availability across the urban landscapes. And so I was just curious if you had looked specifically at that, given also that much of the global south, India in particular, will face increasing heat waves, and the shelter has a lot to do with thermal comfort in the home. So that was one specific question to you, but more broadly, just to the panel, really, really interesting talks. And I was wondering if you could comment on how satellite data sets can be used more for ex-post policy evaluations. So, I mean, I was really interested in what you mentioned in your talk, Chris, about how you looked at, the ethanol policy right at the start, and then sort of, 15 years down the line. And I'm just wondering if more broadly you could speak to how, satellite data sets can help inform ex-post evaluation of policy, which doesn't happen as often as it should, probably.
So to answer your question about shelter and housing, so in the infrastructure inequality study, we looked at housing and particularly durable housing, but we did not look at these infrastructures in silos. So we aggregated everything and looked at cumulatively how these distributions are unequal. But the data is there. So that's awaiting analysis, I would argue. In terms of thinking about shelters, particularly for underserved people and households, the analysis that we did has data on particularly on slums, and that's good and bad news in terms of data availability, because the good news is the data is very detailed. The bad news is that it's the government that identified whether a settlement or not is a slum, right? And defining just an informal settlement is such a challenging task, bottom up, but also from satellite imaging. It's very difficult to identify and distinguish informal settlements. That's a key area that a lot of people, remote sensing scientists, have been working on. And that particularly thinking about informal settlements from a global perspective. And that's because of the heterogeneity in the built environment. I would just throw out an example about a workshop that I attended a while ago at the National Academy, where someone asked, where is the biggest slum in the world? And someone said, oh, you haven't seen it, it's here in the US. And I was shocked because I was coming from India, and I was thinking, oh, we have these large slum areas in India. How can that be? And then I learned that there is informal, rather, settlement in LA that is often not talked about as slums, but there are a lot of issues of underserved people, neighborhoods. And in terms of shelter, one thing that we did not do in that paper is to think about homelessness. So that data is not included in our study currently, but it's available, it's waiting to be analyzed, at least in the Indian context. There is a lot that still needs to be done that way, but thanks for the question.
Yeah, and so, yeah, the question about how to maximize the use of satellite data and maybe both retrospective and moving forward. I think things are going to get better as time moves forward, because historically, I think we've been challenged with the type of satellite data we've had. Landsat, early 80s, high spatial resolution, but temporally not that great. Don't want to discount it. It's a great data set. MODIS comes along in the early 2000s, high temporal frequency, a little coarser spatial resolution, and lots of scientists and like plant sciences and sort of types of areas I'm working in have really maximized that and have allowed us to do some of this backcasting, to see how things have changed. And I think moving forward, if we can sort of hit that sweet spot of higher spatial resolution, higher temporal frequency, many more wavelength bands. I mean, the amount of data, being collected will, I think, a decade or two from now will allow us to do a much better job of looking back and assessing, so how did this do? And I think Sarah brought up a great example of looking into the future in this verification part, which is, I'm thinking these have been drive-bys, someone with a clipboard checking off whether someone's tilled their CRP field up or not, and they're supposed to be in a contract and a set aside for 10 or 15 years as one example. So I don't know, Sarah, if you want to add anything to that or not.
I guess I just add that, to the context of policymaking and policymakers is, the quote of, pictures worth 1,000 words really resonates. And so, even the small video clips that Chris showed within his presentation today, that's exactly the kind of things that I would like to see our satellite data turning into, so that we can use those kind of short clips. I mean, it's a sad reality, I guess, of our humanity, but that your elevator speech is kind of everything, that you get that 2 minutes to really make your point. And you need to have something that can grab, and bringing in images, and especially those kinds of trends over time that we're seeing with ethanol and whatnot, that speaks ridiculously loudly to policymakers who are really trying to look at what that impact is on their constituent base. And so I would like to see the satellite data be able to do exactly what you're speaking to on a number of different fronts that way, to really be able to hit those points home in a direct way that really sticks in people's minds.
Gonna add something?
Yeah, I just want to add my experience working with policymakers and using satellite data and thinking about policies. Policymakers often want good news from satellite data. That's the case, and at least from policymakers that at least I have worked with. When you give them bad news, they're uncomfortable. But that is to say that we have to be engaging more. And then there's a critical need for that. Two examples. One is electrification in India. We showed pictures of electrification observed from Beer's nightlights data set, and the government was super interested in seeing that there is a observable impact on the ground. We use the same data set to investigate economic impacts of demonetization in India. The government was not happy with that analysis. So it's like there is this big data, but how we communicate is critically important. The other thing is, and as a challenge that we have often observed, is that we have more satellite data now than socioeconomic data. And just marrying the two is a key challenge, I would say, for policy analysis.
The other thing that I'll just add, also just thinking of what you all said, is, I think a really amazing part of satellite data is the spatial extent, that you can go in, I mean, from the US perspective, I'll just speak to that, but obviously it's relevant around the world. You can go into any member of Congress's office with these kinds of data sets because they have information relevant to any congressional district. And so that's just so incredibly powerful, and I think, unusual when you think of all the different types of data that are out there. So I'll just kind of add that as another.
I have a question for Sarah and then a general question to the panel. So Sarah, right now, NOAA is beginning the planning of its next generation geostationary satellite suite. So this is kind of in the 2030 timeframe.
Okay.
And right now the concept is there'll be ocean color and water quality measurements on both the East Coast and the West Coast. I'm wondering whether, it's some, will that be adequate for the Great Lakes, and what kind of resolution do you need, spatial resolution and things to get Great Lakes water quality?
Well, I'll probably be pointing out my overall level of ignorance on the technical components of the satellite data and that level of resolution necessary piece. But I think, the data that we have existing right now with it and the level of resolution that we're looking at HABs across the Great Lakes is more than sufficient. I mean, it's really, to my part of this puzzle, it really does provide the kind of data relative. It's at a resolution right now that's allowing scientists to take and double that back to say, okay, let's ground truth this now. Does this cloud, this green that I showed in a couple of those images, does that actually translate to harmful bacteria and the microcystin development that is the actual public health concern relative to those? And so at this point in time, it seems to be sufficient to be able to make those ties and be able to truth check the imagery to the actual biology in the water to identify that. And we're talking, we're very interested, and I think more local that we can get, the better. But similarly, I guess I haven't seen any challenges with the level of resolution we're looking at for the Great Lakes that's inhibited any of the municipalities that are most impacted by HABs at this point from being able to refine, their work. But I think, there's a lot of continued science on that the test between what the imagery is depicting and what's actually in the water, and that might drive maybe some further resolution that we would want to gain on chlorophyll, using different types of chlorophyll monitoring and whatnot, and pulling those pieces out of it instead.
And then my question to the panel, great set of talks, particularly with regard to the food and water nexus. If we're going to be 88% urbanized in 2100, what about transportation, in particular transportation of food and goods to this new urban environment? I know it might be out of your area, but how's that going to change the energy landscape?
Well, here, I'll put my foot in my mouth. So just this past week, as we were talking with these state hubs that are stakeholders, policy decision makers as part of our Viewscapes project and developing scenarios, it was just interesting to hear them and their viewpoint of what transportation might look like and the needs for fuel. I don't know, this might be kind of what you're getting at, but it was like electrification of transportation, personal vehicles and that, but the heavy duty, the bigger trucks, like more on sort of like biodiesel, and that was really being pushed forward. And so like getting rid of corn and ethanol, as a fuel, because we won't need it. Everyone's going to have electric vehicles, but there still is transportation segments that are still going to be reliant on some other types of fuel mixes that probably could still be supported through diesel and through plants. And that seemed to be a pretty optimistic point of view on that. Yeah. Mm-hmm.
I would just add, and this is a statistic that I did not provide in my talk. I should have, which is by the middle of this century, we are expecting approximately twice as much infrastructure that is going to be in 2050 that is remaining to be built, right? And as we are thinking about infrastructure, transportation infrastructure, there is a real opportunity here in terms of thinking systemically, whether we need to transport food from these far off places. Can we grow locally food? And that has been historically the case, that food that is produced locally is what is being eaten by households, right? Because we have this really complex set of supply chains that has been enabled by this process of an urbanization, that we have started to rely on transportation systems. to transport what we need to survive. But I just want to point out that there is a big opportunity between now and the future, and we can do and promote sustainable ways of living, and fundamentally changing how we depend on these resources.
Awesome. Well, that's a really nice note to end on. Apologies if anyone had any questions you were hoping to cover, but we are going to be heading into a break, and I'm sure our panelists would be happy to chat one-on-one. So thank you all so much for coming. I really enjoyed this myself and took a lot away, and